Gabby, number 12. Sure. Okay, and I'm going to drop in the identity sheet here next to it so we don't have to go back and forth. All right, we're looking at 12, you say, right? Okay. So what sticks out to me right away is that we have negative x's, right? Okay, so first thing I'm going to do is I'm going to go to my identity sheet and see if there's anything that covers a negative x like that. So if I go and I take a look and I see, okay, these odd even identities appear to be the one that I need, and the two that I need right here is that cosine of negative x is just equal to cosine, and secant of negative x is just equal to secant. So that would be my first step. Is I can just use those two odd even identities to rewrite that as a secant x and cosine x. So next what I'm going to do is I'm going to go through my identities and look for something that involves either secant and cosine that rewrites that in terms of the other one, right? So I go and I look, start at the top here. So I see that cosine is 1 over secant. So let's use that one, because that rewrites cosine in terms of secants. So that's good. So I have secant times 1 over secant, where I've just replaced the cosine with 1 over secant. And now I have the multiplication of two fractions here, so I'm going to think about secant x as just secant x over 1. I know that we can reduce across a multiplication symbol. So all we're left with here is 1 over 1, which is just 1. So that's my final answer. Landon? Sure. So looking at 8, there's an algebraic thing that I would do right away. So if I look at this fraction, I notice that I have a factor of cosecant on top and 2 factors of cosecant on the bottom. You see that in the fraction? So I just reduce here straight away. Is that okay? Okay. Now if I go to look for identities, the thing that I think sticks out to me right away is that I have that thing. So I'm going to look for an identity that has a pi over 2 minus x inside of a tangent. So I see it right here. So I can replace that all with cotangent . So far, so good. Okay. Now what I'll do is I think the easiest way to deal with this is to think about this as like 2 separate fractions. So I'm going to think about that as the numerator over 1 times the 1 over the denominator. And the reason I want to worry about that is because I'm going to look for an identity that maybe allows me to rewrite cotangent in terms of cosecants. So I'm going to go to my identity list and look for things with cotangents in it. Well, I have this, but that doesn't get me what I want because it's just in terms of tangents. But if I look at this one, I can rewrite cotangent as cosecant over secant. Is that okay?
Yeah.
So that's the one that I'm going to want to use. And then I can reduce across my multiplication symbol. That leaves me with 1 over secant. And if I go and I look at my identities again, 1 over secant is equal to cosine. And that's as good as we can do. Is that okay?
Yeah.
Sure, where to?
Like when you find like the tan inverse is equal to cosecant over secant.
So you mean that cotangent is equal to cosecant over secant?
Yeah.
So the identity I used was here for my identity sheet. Yeah, so this is that what you needed, Victoria?
Yeah.
Okay. Ben?
Could you 11?
Sure. Again, if as I'm doing any of these, I get going too fast or we're not quite sure or anything, stop me and ask, and I'm happy to slow down or re-explain or point something else out. So if I look at 11, there's nothing algebraic really to do because none of these things are like terms to add. There's nothing to reduce. There's no like greatest common factors to factor, so I'm going to go look for an identity. If I look at the numerator, everything has a squared in it. So I'm pretty sure that the identities that I'm going to want to be looking at are the Pythagorean identities. So if I go over there and I look at those, and the reason I know that is because they all have squareds in them. So the one that sticks out to me is the first one, because if I look at the numerator, I have a sine squared and I have a cosine squared in it, and they're all positive everything's being added. And I can add in any order I want. It doesn't have to be like right next to each other. Addition is commutative. So that's what I'm going to use first. Cool. So now I have 1 plus something squared. Again, that screams to me Pythagorean. So I'm going to go look at my identities again and see if there's a Pythagorean identity that involves 1 plus tan squared in some way. I see it here. That's equal to secant squared. Where does my, there you are. And now I have a secant squared on top and a secant on bottom. Those can reduce, right? Just like if I had x squared over x. So I can do that. which leaves me just with secant beta. And we're done. Is that okay, Ben?
Yeah.
Sure, no problem. Jane. Sure. Now 10 can get quite messy depending on the way you try to do this. There's a very important algebraic first step that makes this quite a bit easier. So I notice right away that there's a greatest common factor of tangent. So I'm going to factor off that tangent x as my very first step. Is that okay, Jane? Okay. So now I see that I have two reciprocals, right? I have 1 over cosecant squared and 1 over secant squared. That to me screams like use a reciprocal identity, get rid of those fractions. Like it's much easier if there's no fraction involved. So I'm going to go to my identities list and look for 1 over cosecant. I see that here is 1 over sine, or is equal to sine. And similarly, 1 over cosecant is equal to cosine. So I'll go back to my problem here. So 1 over cosecant is sine, so 1 over cosecant squared is sine squared. And similarly, 1 over secant squared is cosine squared. Feel okay there? Okay. Did you notice anything we can do now? I have things that are squared and being added. That should scream Pythagorean. Landon? Yeah, exactly. Sine squared plus cosine squared is P1. So I can just replace that with a 1. And if I multiply tangent by 1, I just get tangent. And that's as good as I can do. It's all starting to run together there a little bit. If anybody went back to try to look at that, it would have been confusing as all get up. Victoria. 14? Sure. So 14, first thing we'll do is look for an algebraic thing to do. So there's no greatest common factors, right? There's no reducing to do. But I have two fractions that are being added together. So if I wanted to add two fractions, what do I have to add two fractions? A common denominator. Very good. What would the common denominator be in this case? Well, if one of the denominators was, if I had 1 over 2 and 1 over 3, what would the common denominator there be? It'd be 6, right? Just 2 times 3. Everybody agree with that? And I know it's that immediately because there's nothing in common between 2 and 3, right? If I look at 1 minus sine y and 1 plus sine y, is there anything in common between there? Is there any factors in common? No, because we have an addition and subtraction problem, not just like a multiplication problem, right? If it was sine y and negative sine y, those would have something in common. If I had 2 sine y and then sine y, those have factors in common. But 1 minus sine y and 1 plus sine y, there's no factors in common. So my least common denominator is just going to be 1 minus sine y times 1 plus sine y. So I'll multiply the first fraction by 1 plus sine y over 1 plus sine y. And I'll multiply the second fraction by 1 minus sine y over 1 minus sine y. So when I multiply 1 to 1 plus sine y, I just get a 1 plus sine y. And when I multiply 1 to 1 minus sine y, I just get a 1 minus sine y. And then my denominator is 1 plus sine y times 1 minus sine y. Victoria, are you okay with how we've gotten to here? So now if I look at this, there's a whole bunch of algebraic things that I can do, right? If I look at the numerator, I have a positive sine y and a negative sine y, so those will just add to give me 0. And then I have a 1 plus 1, so those are going to give me a 2. Everybody's okay with that? If I look at the denominator, I have two binomials being multiplied together. To do that, I should so if I look at the denominator, how do I multiply those two things together? Oh. Anybody? Just FOIL, right? I have two parentheses multiplying together like that. Things being added and subtracted inside of them. That's it. Should scream FOIL. Do you guys see that now? So this one, actually, there's a shortcut to the FOIL, because if you look at this, I really have like a plus b times a minus b. You guys kind of see that? That's the difference of two squares factoring pattern. So I know when I FOIL that out, I'm really just going to get like a squared minus b squared. So in the interest of time, I'm going to use that shortcut to avoid having to do the foiling. But if you missed that and you FOILed, you'd end up at the same place as I did here, just with a little extra work in the middle. But that's not the end of the world. Victoria, so far so good? Okay. So any more algebraic things to do at this point? Nah, I mean, the only thing you could do is like, you could factor the 1 minus sine squared as a difference of two squares, but then you're just back to the previous step, which is probably not very helpful to us. So it's identity time, right? If I see a 1 minus something squared, I have ones and things squared. What set of identities would I probably want to be looking at? The Pythagoreans, right? If I have things squared and then one being added or subtracted, that should scream Pythagoreans. So if I look over here, there's nothing that has just a 1 minus sine squared in it, right? But if I take the 1 and replace it with sine squared plus cosine squared, I can combine that sine squared and minus sine squared, and that seems like a pretty good deal to me. Everybody's okay with that plan? Victoria, does that make sense to you? So that's what I'm going to do here. Where were we? There we are. So those two can combine, which is great, because now that allowed us to go from having two terms in the denominator to just having one term in the denominator. Very cool. Getting much simpler, right, as we're going. Went from two fractions to one fraction. Inside that one fraction, we went to just like one term over one term. This is getting better and better. Here's the final trick that I'm going to do. So I'm going to separate these into the product of two fractions again, like we've done a couple of times, by taking the numerator times 1 over the denominator. Everybody's okay with me doing that? And the reason I wanted to do that, is now it's really clear that 1 over cosine squared, that's a reciprocal identity that I'd want to use, right? So if I go look at my reciprocal identities, 1 over cosine is equal to secant. So 1 over cosine squared should be secant squared. I still have that 2 out front. But that's as good as we're going to be able to do, right? We got it down to the product of a constant and a single trig function, so not going to be able to get that any simpler than that. Victoria, does that feel okay there? So again, the first step, the trickiest step, would have been making that common denominator to add the fractions. After that, things went pretty reasonably, or pretty similar to the other things that we had done to this point, where we're just kind of, we didn't use any weird tricks or do anything crazy. But that first step of getting that common denominator and getting that common denominator correct, would probably be challenging for the first time doing something like this. Do you guys want to do some more? Emilio? 7? Sure. Okay. So there's nothing algebraic I can do, right? I just, 2 things multiplied together. They're not the like term, so there's nothing algebraic I can do. So to me, I'm going to go look at my identities. So I'm going to look for things that have cotangent in it that I can rewrite in terms of sines, or look for a sign where I can rewrite it in terms of cotangent. So I'll just start at the top of my list. So first thing I see is that I can write sine as 1 over cosecant. That's not helpful for me because I want sine in terms of cotangents. So that doesn't help. I see that cotangent is 1 over tangent. Not helpful to me because I want to rewrite cotangent in terms of sines. So I'm not going to use that one. The next one I see is here. Cotangent is cosine over sine. I like that one because it has a sign in it. Is that okay? So I'm going to go back to my problem. And where the cotangent was, I'm going to rewrite it as cosine u over sine u by using that identity that we just found. And then I still have that sine u, but I'm going to write it as a fraction, like sine u over 1, since the other thing was a fraction. It helps me if I'm dealing with one fraction, one not fraction, to rewrite the other one like a fraction so I don't do something stupid. Okay. If I have 2 fractions that are multiplied together, I can reduce across that multiplication symbol. So the sine u's can cancel. And then we're left with just cosine u over 1, or just cosine u. And we're done. What do you guys think? Does this still feel foreign? Getting easier, hopefully, a little bit? Probably some of us still need a bit of practice. Maria?
It's just like problems like number 10. Like, I don't understand which one to find for the formula. Or like
for the identities?
Yeah. Because like there's so many I don't know either if I can, secant, or like.
Right. So before I would do looking for any identities on any, typically I start by looking for algebraic things to do. So on this one, I started by noticing that I had a greatest common factor. Each of the terms had a tangent in it. So I started by factoring the tangent out. And that helps me enormously. When I look at the next thing, now looking for an identity, what screams at me is that I have 1 over something. Right? Do you see that? So I can use a reciprocal identity to get rid of the fractions there, which is always going to be my preference, right? If I can get rid of a fraction, that's usually going to be a good thing. Makes our problem simpler. So that's where I would go first, is I'd go, okay, 1 over cosecant is something. What is that? I'd go to my identity list and see that it's sine. Is this helping at all? Kind of talking about my thought process is like how I know where to look.
It's like better than before.
Yeah, so again, the thing we have to keep in mind is, what are we trying to do? Right? We want it to get simpler. So again, like no fraction versus fraction, no fraction is simpler, right? That's what I'd want. So if I have a situation here where I have 1 over cosecant and I can turn that into something that's not a fraction, that would be my first thing I'd want to look for, right? Even though I have cosecant squareds and secant squareds and tangents and it's all floating around in there, I'm not looking at the identity. I'm looking at the fact that I have 2 fractions there that are being added together. So either I need to make a common denominator and add those 2 fractions, which I would prefer not to have to do if there's a different way to do that, or I can try to find an identity that would allow me to get rid of the fraction. That's the route that I would take. Does that, like, giving some higher level, like, what is my strategy that I'm trying to employ here? Because if I go to the next step then, now no fractions. So now, okay, now it's time to look for new identities. The thing that catches my eye is I have 2 things that are squared being added together, right? That to me screams Pythagoreans, because the Pythagorean identities all have like sine squared and cosine squared, or tangent squared and cosecant squared, secant squared and tangent squared, or cotangent squared and cosecant squared. So they all have like the squared things in them. So that's where I would go on this one, is that's what would catch my eye, is because it's probably a way to turn that into 2 things into 1 thing. Because again, like if I have, x plus y versus z is simpler than x plus y, right? The addition is what I want to get rid of to make the problem simpler. So that's why I would be going to the Pythagoreans, because it's the only identities we have that allow me to get rid of addition. So if I have addition, it's probably going to need to use some Pythagorean at some point, or we're going to have to change the forms of something so things can combine or cancel or something. Is that? So it turned out that I never really touched the tangent. Once I factored that thing out, it's like, okay, there's nothing that's going to immediately interact with until I sort out whatever's in the parentheses. Now, if whatever was in the parentheses didn't turn into a 1, it's very possible I would have wanted to go and do something to tangent so that I could continue to cancel things out. But until I sorted out what was inside the parentheses, I wasn't going to touch the tangent part. Does that helpful at all, kind of talking about these? Okay. So let's do this before we move forward. What I'd like to do here today is give us some time to do some more practice. Of course. So why don't you guys find a partner and look at the review, and we're just going to work on the first page of the review. Or I'm sorry, page 1 is just directions about the test format. But page 2 of the review is just more of these simplifying problems. And that's what I'd like you guys to spend some time here working on. to get a little bit more accustomed to this process, using your identity sheets. I legitimately want you to find a partner and like talk through what's going on. It's enormously helpful in these kinds of problems where it's not doing it the same way every time, to have someone to talk to and like explain your reasoning and like what you think you can do or can't do. I promise you it is going to help if you're able to kind of have a conversation with somebody that's kind of at the same level as you are and talk through, hey, is this possible or that possible? Which one do you think is the better one to do? You know, like, oh, I wouldn't have thought to do that, but I think that's a great idea. These are all things to help develop some intuition, because that's the piece that you're missing right now, Maria, right? You just see a bunch of stuff and you're like, I don't know which one would be a good one to do and which one wouldn't be a good one to do, right? Because we don't have any intuition yet. The way to develop that is to do some problems, have a conversation with somebody, try things, have sometimes that work out, sometimes that kind of not be very helpful what you do, figure out kind of like, oh, did I make an algebra mistake here? Am I just not, is there another identity or something different that I should be doing? These are all things that like you got to kind of figure out by trying and doing stuff. Do you guys cool with that plan? You guys get where I'm coming from? To help a little bit, and just minorly help, but it'll make life a little bit more convenient. I have an identity sheet for everybody, so you don't have to keep like flipping back and forth on your computer between a million different pages. So here's one that you can physically hold in your hand. Also, while I was printing these out, I decided to just stick a unit circle on the back with the inverse information on the bottom there. So like was on the last test, all of this stuff is now in one place. Please hang on to this. I don't have like infinitely many of these copies of this, so like put this somewhere safe after you're done with it so that you can hang on to it and continue to use it. Ben? Absolutely. You can always print your own afterwards, because again, all this stuff is in the content library. You can reprint it for yourself, but this is the printout that I'm going to hand you now for once. To make your life easier for today. And hopefully in the future, if you hang on to it, don't lose it. But I think it really helps to have something to look at while you're doing the prompts and not have to be like toggling back and forth through a trillion different windows on your computer or whatever. And while you guys are doing this, I'll be kind of up and moving around and talking to you guys. And if you have questions about things or want me to look at something or check something, I'd be happy to do that, or even just help you kind of get started on anything. But you really you need to be doing this right now. Let's use this time. Let's get better at this. I acknowledge that this is hard. This is a difficult skill straight away, and some of us will catch on really quick, and some of us might take a while to kind of catch on. And that's okay. But today, let's spend our time in class actively trying to get better at this. Okay? Hi, Victoria. Are you raising your hand or just stretching? Okay. Hey, Domenico, you have a Chapter 4 test in study hall or testing room? The testing room after school? Don't you have an 8th hour study hall? It's okay if you don't want to do that. I remember at one point you asked me to do it in the testing room and then can I do it 8th hour? And it's that's fine. That's fine. As long as I just wanted to remind you, because at one point it felt like you had forgotten that. cosines would cancel.
Okay.
And
Yeah.
you'd be left with sines. Sure. Hi, Emilio.
So I found the best fit, like,
Can you cancel it out? So it's just like that. Like the cosine. Just replacing the tan with the identity that you chose to but that equals something.
oh,
What if it didn't do the close sign?
I got it.
Can you cancel out across multiplication? But it's not that. I think you can. I really do. I think
Like this.
like when you cancel it out. I don't
think we can.
so why are you putting it in this spot? Because you're going, right, I know, so I'm going, the opposite
So it's
Keep
negative
side
1
away.
negative 2 pi.
Oh, no, but then
Negative 3 pi.
It's gonna be hard.
We're going clockwise because it's negative.
Yeah.
So this is negative 1 pi.
Right.
There's negative 2 pi.
But right now.
And negative 3 pi. Negative 2 pi is better than 2 pi. You're, should be down here.
I thought, I don't think you can when I say that's positive, I thought that would.
Cancel out and just get sides.
Well, if you're going positive 2 pi to 3 pi,
That would
you're going 1 pi, 2 pi, 3
Come
pi.
on.
Positive 2 to 3 pi is up
This
here.
whole thing is just fine, just step one.
That helps me.
Going 3 to 2 is not right. Positive, negative. Greater than positive 3, but less than 2.
But if it was pi and 2 pi, it's here.
If it's negative 2 pi to negative 5.
Very specific.
Right,
Well,
I said it's
oh,
pi
pi to
and
2,
2 pi.
yes.
Dude is such a good move right now, right? See, I wanted to see that, but it just doesn't make sense. I know, you have to read the book to actually understand.
Yeah, no, I understand.
To be fair, I only read half the book.